All right. So today we're going to learn about relays. What's a relay? Well, it's a type of a switch that allows a small current to control a larger current. You want to see what it looks like in the up close in person. There's one right here. That's a full size one. And here's one right here. He's a half size one. So, what do you get when you wrap a whole bunch of coils of copper wire around a steel rod?
Electromagnet.
Electromagnet, correct. If you look really closely at this guy, can we see him closely? Not so much.
Somewhat.
Let's give him a little other direction here. All right, if you look really closely at that guy right there, I'd like bring your attention to, let's see, this right here is a contact. This right here is a contact. This guy right here is a bimetallic strip. As you can see right now at rest, this guy is sitting against this contact. When you apply voltage to the electromagnet, what happens is it'll pull that strip over to the other contact, therefore creating the switching action. Okay, follow me so far? All right. Now, I passed everybody a relay so you can see there's a little baby wiring schematic on the side of it. Help you make a little bit more sense to what you're looking at here. So, they work similar. Half-size relays are made to control a slightly smaller device. The full-size relays are meant to control things like headlights and things like that operate on a heavier scale. Right. So, on this schematic, that's the same thing as stamped into the side of the relay that I shared with you. You see numbers, 30, 87, 85, 87A, and 86. The same thing is true with this guy up here. You got the same numbers, right? 85, 86, 87, 87A, and 30. The 85 and 86 numbers are actually your electromagnet. Okay? So on the bottom of your relay, come here you. On your bottom of your relay, this is also, that was upside down. Let me flip him over. Alright, so now it's really upside down. What am I doing? I'm confusing myself. So this guy is 30. You can't really see that. Let me try a different color. This guy is 30. This guy here is 87. I think he's 87A or is he 87? I think he's 87. Yeah, he's 87. This guy is 87A. This guy is 86. And then this guy, of course, then only leaves the last one that's 85. When you go out to the shop, for the things I'm setting up for you to do in the shop, I'm going to give you this setup here. I'm also going to give you a meter, which I have to go grab. And you're going to test out 3 relays like I'm going to show you here. And you're going to tell me if they're good or they're bad, or if they're shorted to power, or if they're open circuits inside of them. But you're actually going to test them as I'm about to demonstrate. So let me go grab a meter here. Alright, so I got a meter that works. Sorry for the delay. So what we're going to do is we're actually going to test this relay 2 different ways. We're going to check it with it energized. We're also going to check it with it not being energized. And the reason why is because of the switching action. Right now, with no power hook to it, you actually should have continuity between pins number 87A and 30. So we're going to check that first. Let's just find our one random relay here. We'll just work with it. Okay. I got my handy-dandy ohm meter. It's set up for ohms. I have it set to the lowest setting. It's just 200 because I expect to have like a low amount of resistance through this. Anytime you use an ohms meter, you're supposed to cross the 2 leads like so, zero it out. I don't know why my zoom didn't zoom, but I got to zoom back in here so it makes it easier to see. There we go. All right. We can zero it out. Now, if you look at this meter right now, my leads are not touching, right? That means I have infinite resistance. You see that little 1 thing that's on there? That means that there is no continuity through anything. Okay? That's what you get on these meters. Sometimes they'll give you an infinity symbol. Sometimes they'll just have like lines that go across. This means power cannot flow. Okay? If I would cross these, ideally, if there was no resistance in these leads, it should say 0 when I cross these, and it should zero itself out. These are cheaper meters, so they're not going to do that. Okay? Now, all I'm checking for is continuity through the 2 terminals here. So, without applying any kind of power to this relay, I'm only going to check right now through pins number 87A and 30 to see if they actually have continuity through them. So I'm going to throw my meter under there, and then I'm going to look for 87A and 30, which is that guy there, and this guy here. And as you can see on my meter up there, I have power flowing, right? Mm-hmm. Now, if this switch was working properly, I should not have continuity through 87 and 30. So I'm going to check that while I have it de-energized. So there's 87 and 30. Nothing showing up. I have infinite resistance, right? So that means that that thing is not shorted. So if I'm going to check this then, to make sure that switch is switching, we should have the inverse happen when I apply power, right? I should have continuity between 87 and 30, and no continuity between 87A and 30. So I have my handy dandy power supply here. This thing here cranks up to 25 volts. We only need 12 of them, so we're going to adjust it up to about 12. And I have fuses in this, so you guys can't really play around with it too much and hurt yourselves. I even have them color-coded, red for hot, black for earth, but it doesn't matter on a relay which side you connect it to, but you are going to make sure you hook it up to 85 and 86 because that's our electromagnet. Now take a listen real quick, okay? Be real quiet. You hear the clicky? Yeah. That's one indication that at least the electromagnet part of it's working. It doesn't mean the relay is good just because you hear it click. A lot of people make that mistake for like trying to fix like a fuel pump or something that's bad in the car. They turn the key forward. They go, oh, the relay is clicking. It must be good. But it can click all day long, and you can still have green stuff growing in there. All right, now this is going to take a little bit of like having 10 hands on my behalf because I have to hold this up. When you guys do this in the shop, I suggest doing it in teams. All right, so I'm going to 30, and I'm going to check 87A, which I should have. There we go. There's 87. So now I have continuity between 30 and 87. And 30 to 87A, I have nothing. If I took the power away, it's going to switch back. So this is a good relay. Was a good relay.
Was a good relay.
Now, actually, these take a pretty good beating. Now, so far, you guys understand? Good?
Yeah.
Questions?
Yeah.
No.
Got it? Rock solid?
Yeah.
Test it out.